We're live.
Hi everyone, welcome to WeeklyWed from Business School of AI. WeeklyWed happens every Wednesday at 9 a.m. Pacific time. It's a community event by Business School of AI where students of Sudha from LinkedIn Learning, Business School of AI come together to have continued learning here. WeeklyWed hosts international speakers from all over the world talking about AI, AV, and IoT. This WeeklyWed, I will be telling about responsible agent AI. To introduce myself, I'm Yashaswini Viswanath. I'm an AI researcher, Sudha student. I have been working in Bangalore for last 13 years, and currently I'm doing my PhD in machine learning. And ethics is something that's very close to my heart. And I strongly believe that AI innovation should not be curtailed, but there has to be guardrails such that the AI innovation does not cause harm. In a couple of sessions previously, we have seen about agents, multi-agent systems, and we have also had sessions from Sudha who taught us about agents. Also, I would like to state that LinkedIn Learning has a course by Sudha, which is releasing, and the production is done for that. The second point is we are at Business School of AI. We are having an Agent AI course, and we are trying to bring the best in class about Agent AI to all the students here. If you're interested about Agent AI, you can join the MailChimp that's there so that you can write in, tap onto the newsletter, which is getting published. And that will have all the information about Agent AI course and anything that's related to Agent AI. Okay. Today, when I talk about responsible Agent AI, why does it matter? It matters because Agent AI has access to LLMs. And these LLMs have a certain kind of bias in them. They may not be fair. On top of all these possibilities, it is very difficult to interpret and to explain the decisions of these. So when we look at all these aspects, we come to governance of Agent AI. How do we govern? When we talk about an enterprise setting and we want to utilize this Agent AI at the enterprise level, until and unless there is a go-ahead by the ethics committee, we will not be able to see this in production. About ethics, we have had sessions before at WeeklyWed where we talk about hallucinations, we have talked about inclusion, we have talked about fairness, and all these concepts. Today, I'm going to tackle something that's very specific to Agent AI. So first of all, I'm going to tell that it's a paper readout session that we are having today. I'll be reading out two papers. I have carefully curated this because this has the latest. It's released in 2024 and this has the latest content. Understanding this content will help us to implement this in our enterprise, in our companies where we work, and where we work as a consultant. And this forms the basis. At this point, I would like to say that as students of Sudha here at WeeklyWed, I am sure each one of you are aware of ethics, and I need not tell about ethics again. But yes, in the agent AI context, which is fast evolving, and trying to come up to speed about agent AI is really difficult. And when we have to think about the responsible aspects of agent AI is a lot more difficult. But today's session will make these difficult aspects easy, and we will have this. I will share 3 papers initially in the chat box. These are the 3 papers that I'm covering today. Just a second, sorry. Yeah, I would like to share my screen and go over the content that I have tried to collate here. So first off, in the first 5 minutes, I want to quickly brush up what are agents. Agents, goal-based, skill-based, they plan and they do tasks, they invoke LLM, they have memory. So these are agents. Next, I would like to tell about multi-agents. Number of agents coming together in a collaborative manner. It could be delegation, or it could be message passing. So those are agents, multi-agent systems. We have seen all these things previously. So let me share the screen and we will look at the responsible AI aspect of what we want to discuss today. I hope you're able to see the screen.
Yes, we can see the screen. Yeah.
Yes. This paper is a gold mine of information related to responsible agents. I have shared it in the chat. It is by Depmalia Biswas, and it is called Stateful Monitoring and Responsible Deployment of Agent AI. The reason why they have the word stateful here is they're trying to draw a parallel between agent AI and distributed systems. So this particular table that you see here is the crux of this paper, and I would like to highlight what it is telling. So there are multiple legs of responsible AI. And what are the factors in each of this responsible AI? And how is it for LLM APIs, for fine-tuned LLMs, LLMs with RAG, and AI agents? So I want to tell the students here that this infographic that is there will empower you to not just think about agent AI, but to even look back and look at LLMs, fine-tuned LLMs, and LLMs with RAG. So before I move into this, I will quickly tell what are LLMs. LLMs are large language models that are pre-trained on a large amount of data set, like Wikipedia, websites, books. Fine-tuned LLMs, we take the LLM and then we fine-tune it with our data and train it. LLMs with RAG, we give the context of the document and the LLMs understands the context in which it has to answer and does this. And we have discussed about AI agents. When we look at reliability and data consistency, LLM APIs adhere to the consistency of data during prompting. Fine-tuned LLMs need to have the training data to be consistent and balanced. LLMs with RAG, the data should be aligned with the prompting and be consistent. AI agents. Adherence to the consistency of data during prompting and while passing to other models. So at this juncture, I want to tell what is prompting. Prompting is the mechanism of trying to give instructions to an LLM to get a particular output. And this is what they're talking about. Moving on to the next aspect of responsible AI, reliability with a factor, what we call as bias of fairness. LLM APIs are pre-built LLMs. It can perpetuate and amplify the harmful biases present in the training data. For example, the training data has some gender stereotypes, then even the LLMs that are trained on it will have gender stereotype. Fine-tune LLMs. How does it fare? Related to bias and fairness. Fine-tuning the LLMs with unbiased data reduces the chances of unfair responses. I want to bring to the notice of the students here that this is one of the bias mitigation techniques. They use fine-tuning in order to remove bias. So I will put it across again. Fine-tuning the LLMs with unbiased data reduces the chances of unfair responses. This is very important because when we talk about bias and fairness, it's not just that we talk about it, but we should also have mitigation capabilities. We should try to put in our effort towards building out algorithms, building out mechanisms so that the bias is mitigated. LLMs with RAG. Retrieval augmented generators with unbiased data reduces the chance of unfair responses. Because we give context here and we say, hey, please give the answers from this document, and we are sure that that document, that information does not have bias, we are making sure that the output of the LLM with RAG is bias-free. AI agents. How does bias and fairness fare in the context of AI agents? Chances of unfair and biased responses can get amplified by using multiple LLMs, but can be reduced by using prompts that contain the unbiased data. See how important this is. The number of LLMs that we use, multiple LLMs, it will propagate the bias. But prompting, giving the prompt in such a way, we ground it. This is called grounding. We ground it by giving a prompt that contains unbiased data and say that this is how the answer has to be done, this is how the task has to be accomplished. We have had a session on hallucination by Susanna Raj, and hallucination is a well-spoken topic now. In fact, it is well researched where they have categorized hallucination and tried to have hallucination mitigation. Hallucinations are likely as the model gives responses based on large training data. Reduced to some extent as the model is retrained with curated enterprise data. It's reduced to a significant extent by limiting the space of the generated responses. What about AI agents? Hallucination likelihood is amplified as a result of using multiple LLMs. I just want to take a pause here and reflect upon this statement and think how this will actually happen. An AI agent has multiple tools, and as a part of these tools, it'll invoke multiple LLMs. And because of using multiple LLMs, and these LLMs have hallucination, there is a very strong probability of an AI agent having hallucination. But yes, if you make the LLMs hallucination free and invoke the same hallucination free LLM at my AI agent, it will not have hallucinations. So all of these things, they come to one single point: how the LLM saw the agent. If the LLM is being responsible, the agents which use those LLMs are responsible. Accountability. Very, very important topic. Human should be in loop while doing the LLM deployment, training and deployment, and in the build phase. And human feedback is leveraged to improve the model. This is common across all of them. LLM APIs, fine-tuned LLMs, LLM with RAG, AI agents. These are some of the spokes of responsible AI. Moving ahead, we look at reproducibility. What is reproducibility? We want the same thing to have again. If we create a model and run an algorithm and get some outputs, the next time we do that, we want the same outputs. So let us see here. There are two factors: evaluation during training. LLM's performance can be evaluated either by manual testing, by keeping humans in loop, or by using statistical measures. There are different statistical measures available to evaluate the performance of LLMs, like perplexity, BLEU, rogue, etc. If we hear the word perplexity, it comes to mind that 2024 people have been talking about perplexity. They have been using perplexity. They have tried to make perplexity part of their pipeline and try to do the evaluation. Inference evaluation. See, there are metrics available to measure the LLM performance during productionization in terms of handling incoming requests. There are completed requests per minute, time to first token, inter-token latency, and end-to-end latency. These are the metrics. Inference evaluation. So how do we understand inference evaluation? I want to take a brief stop and ask here, can any of you tell me what you understand by inference evaluation? Okay, I'll continue with the explanation. Inference evaluation are metrics that measure the LLM performance. Because here we are trying to look at the inference and we are trying to evaluate it. When are we trying to do this inference evaluation? During productionization. On what basis are we trying to do this inference evaluation? Incoming requests, completed requests per minute, time to first token, inter-token latency, end-to-end latency. Explainability. Now, explainability can be defined as the way to explain the decisions taken by the AI. Here, when we see AI as decision makers, we need to know why they have taken a particular decision. The factors here are providing evidence, what we call as chain of thought. Chain of thought prompting for the LLM APIs, the chain of thought prompting can be used to provide the logic behind the LLM response. So generally we think that chain of thought prompting can be used to get responses. Here we are trying to see it from an angle of responsible AI and telling that chain of thought prompting can be used in LLM APIs to provide evidence and talk about explainability. Training data can be adjusted in such a way that the LLM response includes the chain of thought prompting. That is for fine-tuned LLMs. And for LLMs with RAG, the RAG plus chain of thought prompting can solve the gap of providing logic to the LLM response. So you might be wondering, what is chain of thought prompting? Chain of thought prompting is where we try to reason with the LLM, trying to ask the LLM to give us steps, trying to reason with those steps, and build out the response. It is difficult to produce such a chain of thought mechanism in agents because the underlying mechanism involves multiple LLMs. So we saw reliability, reproducibility, explainability. The last one, which is the most important for any adoption. However good a model is, however best performance it shows, unless and until it is secure, the enterprise will not take it. Here, we need data guardrails and access guardrails. What are data guardrails? Secure cloud platforms to train and deploy LLMs, which are provided by hyperscalers. Who are the major hyperscalers? Azure, AWS, GCP. They provide the necessary landing zones, infrastructure, and tooling to securely host the data and models. Access control. Access control to the data under the LLMs can be configured within the cloud platform as per the use case. Cloud platforms also provide default standard protocol to access the data use in LLMs. This is how we look at the responsible AI for agent AI. I would like to pause here and take some questions and then move to the next interesting topic in this. Any questions?
Yes. So one question I have is, how do you quantify the bias in a particular LLM? Like, can you, because bias is very subjective, I suppose. So if you say, yeah,
all these biases, or if you look at the mirror, right, the fairness of it, there are 21 definitions of what is fairness. And we have looked at this earlier in the context of AI, Fairness 360, the IBM Fairness 360. Similarly, the metrics hold good for LLMs because the notion of fairness remains constant. It's just that the amount of data is large. But what is fairness? How do we mitigate it? That still remains the same. And anything that is very specific to bias mitigation in LLMs is focusing on large amount of data on which it is trained and how to identify the bias in the training data itself so that it won't perpetuate. Yeah, did I answer your question, Suresh?
sort of, I think, yeah. So it is also very based on a particular system saying, the bias is 50 or bias is 70, right? There's a scoring mechanism that's already been set, I think, correct?
Yes, yes. So generally it will be, so there are multiple indices. There are multiple metrics like Thiel index, disparate ratio, statistical parity difference, average odds difference. All these metrics, they have a mechanism to compute it. And when we run the computation algorithm and check how the LLM is faring across all these metrics, we will come to know how fair it is. And regarding bias mitigation, there could be there is in fact pre-processing, in-processing, and post-processing bias mitigation.
Got it, Yash. Got it. Thank you.
Yes. Any more questions? Shall I go to the next aspect of agent AI? You can shoot any questions on agents. I'm going to answer them. Okay. I will move ahead for the next set. So if you see here, this is a reference architecture for designing an autonomous agent. And here, the responsible AI plugins. So what are the kind of responsible AI plugins they are looking at? Continuous risk assessor, black box recorder, explainer, multimodal guardians, co-versioning registry, Abiom registry. Let us look at each of this and understand what they are. Yes. So a continuous risk assessor continuously monitors and assesses the AI risk metrics to prevent the misuse of the agent. We have been talking a lot about the use cases of agents, where it can be used, but what about the misuse of the agent? And ensure the trustworthiness of the agent. A black box recorder records the runtime data, which then can be shared with the relevant stakeholders to enable transparency and accountability. The idea of a black box, historically speaking, comes from an airplane where there is a black box and it records what is happening in the cockpit. Here we have black box in software, and in the context of testing, we say black box testing, where we don't know what is inside, but we still test it out. In the context of software engineering, it is related to this, and in the context of artificial intelligence, we say that neural networks are black boxes. Transformers are black boxes because we do not know what leads to what. A black box recorder records the runtime data, which can then be shared with relevant stakeholders to enable transparency and accountability. What do we mean by transparency? That is, what is working and why is it working that way? Accountability is, yes, it is working like this, and who is responsible for it? The recorded data includes the input, output, and intermediate data for each component within the architecture. Such input, outputs, external tools, and other responsible AI plugins, guardrails, are required for agents. All the data needs to be kept as evidence with the timestamp and location data. Here, this paper suggests a very beautiful solution to this of using blockchain-based immutable log. In this context, I would like to talk about blockchains. Blockchains are ledgers. They are software ledgers, contracts that are drawn, and the data that goes into a blockchain is secure and validated. A specific type of monitoring is called guardrails, which is a very important layer for the responsible AI plugins. They're designed to control the inputs and outputs of these responsible AI agents. This guardrail can be built on responsible AI knowledge based or responsible AI narrow models. The Ray FMs can be fine-tuned or can call upon the Ray knowledge base to support the Ray controls. So now let us dive deep. There are different types of guardrails. The first one is an input guardrail. Where is that applied? It's applied at the inputs received from the users. So this is at the prompt side, such as refusing to or modifying user prompts. For example, some user prompts may contain personally identifiable information and need to be removed by employing data de-identification and anonymization. What is anonymization? It is an old technique that has been around ever since data science took over, maybe a decade and a half back. Anonymization is having personal data without being able to link it to the person to whom it belongs. But we still need that data, and to train it or to generate the particular answers related to the PII. So at that point of time, we will be incorporating anonymization. Output guardrails. Output guardrails, they modify the output by preventing or refusing the retrieved data. So we get the data, we try to do the task using that, and then when it is giving the output, we try to have guardrails. Also, whitelists and blacklists can be established to identify actions that are permitted and prohibited respectively. We have had a lot of information about responsible AI plugins. The last one that I will be talking about is the explainer role. When we have an agent, how does an explainer role come in? What are its capabilities? What are its limitations? What is the rationale behind the intermediate or final outputs? The ethical and legal implications. See, whenever we are trying to verify the explanations, it can be challenging. The external system, including tool agents, they have problems with explainability. How do we mitigate them? The agent can refuse to run the external tools, agents, if there is questionable methods there. Also, if there is a rapid release about fine-tuned models, multiple variations coexist and are serviced at the same time. The co-versioning registry can be applied to co-version the AI components, such as FMs and tuned FMs. Now, I would like to have a discussion here on what each of the students here thinks about agent AI, responsible AI. Why do you think they are important? What do you think are the fail-safe mechanisms one can have? Yeah. Can we have just two questions from each of you and keep this interactive so that we can brainstorm and use this space as a soundboarding mechanism.
Yeah, thank you, Yash. I think agent AI is the next wave of the future, but I think having controls in place is the most important step we are in right now, so that we can safely integrate it into the real life of productionizing many things. I think in terms of what are the mechanisms, I think it needs to be validated by humans so that it is acceptable for them. But how do you get the human in the loop is something that I'm struggling with to make sure, how we can answer that. So I'm not sure about that.
Suresh, I would like to put the question back into your court
Mm-hmm,
and would like to ask you to think from your experience of the research paper that you have written
mm-hmm,
and like the robot for the elder care.
mm-hmm.
Um, this agent, the word agent has come from the world of reinforcement learning.
Right,
And when you talk about robotics, that is the first step where the agents came in. And now we have agents in the context of LLMs.
right.
Uh, I am sure that you have had great deal of experience in the robotic world.
Mm-hmm.
And if you can draw a parallelance of how this agent AI, what I'm talking about, is applicable to your robots, and how do you mitigate there? We would like to hear about it.
So robots is not general purpose robots. So it is a particular context. It's particular use case. So as long as the use case is satisfied, 70% or 80%, I think we can say that that robot is useful for that particular use case, because you cannot just deploy a robot into a general world and say it can take. It's not human being yet, right? Likewise, I think this agents needs to be validated by a set of like a old age community people, or healthcare persons, things like that. I think it needs to be validated in the context of the use case. As long as it satisfies the use case, I think that is how we can validate it. I don't know if I
Okay.
answered your question. That's my
Yes.
thinking.
Now,
Also, Renee and Ananya wrote something in the chat.
yes. Renee, would you like to voice it, or shall I read it from the chat? I think ethics is important, for example, because it might be important to know who is accountable for something. Yes, that is why we touched upon accountability. Generally, what is happening is when an AI makes a mistake. So if you go online and if you check research papers, there's a lot of research papers that have come on this topic. That is, when an AI makes a mistake, who is responsible? Is it the person who created the AI, or the AI itself, or the training data which fed into this AI? Accountability. Accountability is very, very important. And it is being called out, and research is going on to improve the mechanisms in which accountability can be improved. For delegating agents, wondering how do we configure controls? How are the agents discovered for delegation? Okay, maybe there is a repository of agents, and the super agent has access to this repository of agents. Each of these agents have a particular tool, particular skill associated with them. And if there's a mapping between them and what those agents can do, then the manager agent can delegate it to the right agent. So today it's me asking all the questions. Hmm. I want one of you to tell me 2 use cases of agents.
Hello, this is Adam.
Hi, Adam. How are you? Can you tell me 2
Really,
use cases of agents?
yeah, I could think of one at least. Finding the right price in a local area. So you could set an agent to look in various ways to see what would be the highest price, lowest price for an item. That would be one aspect I could think of setting up an agent. Another one might be even knowing what to carry in the area. So you could look at what's your product mix, ethnicity, things like that for demand. I'll let you go with that for now. Thanks.
Okay,
I wish
no,
I
no.
wish I'd seen the class, but I could see setting up agents to do that quite uniquely.
Okay. I'm gonna ask you one more follow-up question.
Mhm.
Now, when I say, I'm gonna just ask a very generic question. What is the goal of that agent that you're trying to talk about?
That's what we have to go for. Thank you. The most beneficial price for the right product mix to offer in, say, a small store. That might
Okay.
be aspects of it. Yeah, you have to work backwards. You're right. I went straight to solution instead of, okay, what's the real problem here?
Okay. Now, the next question that I'm gonna ask is, how is the task defined for this agent?
Well, it could be various, and a lot of it deals with geography. Is this a town, or what are you trying to establish with it? Is it a whole distributor chain, supply chain, or is it just a single, say, a mom and pop store? Or are you a franchisee for a larger corporation? So all of these,
Yeah, those are environments.
yeah, but what ultimately you would want maybe is a keyboard, a front page showing you where you are currently and what it recommends is also in the area. And it would have to be integrated between both the product mix and the price.
Okay.
That's one thing I could see.
So how can we summarize the task? And because here in LLM, we cannot give a very big task. We should be very succinct and tell the task. This is the task. Do it.
Okay, say you owned a Shell station and you were a franchisee. You would have limited shelf space, so you would have to carry only what they allow, but also you might be allowed, say, 5 or 10% of local content. And so that
Okay.
5 or 10%, you have to decide quite diligently what the price and the product mix is going to be.
Super. We have the goal, we have the task. Now, how do we feed in the intelligence? How does the agent try to decide what has to be kept, what has to be bought, what has to be sold?
I could see a recommendation list to the person. So there's a person in the middle to finally decide, but a recommendation list of local products that seem to be selling well or that are recommended or can be scoured by newspapers or other ads or other social media, or even eyeglasses, because you're going to have a whole bunch of, like the always on microphone, you're going to have a lot of content coming through. And so, okay, that's your input stream. Now, what does it decide? Well, it could have various rules behind it. I'm not really clear what that would be, but it might be even product by product. So you might have snack seeds, sunflower seeds, that sort of thing. That might be one agent even, to just say, okay, here's a local thing for this specific item, or you could look at total sales of an area. I'm just guessing. I'm just putting these ideas out.
Yes.
But thank you. This is
Okay.
great.
Okay. I would like to ask one last question to Adam. What is your motivation to learn about agents?
Um, so a lot of this is efficiencies that are kind of locked in the system that you don't see until you interrogate it. But that's one of my takes on what agents can and will be. And
Okay.
But I might be wrong. I'm just kind of
Trends.
turning back
How
on
about trends,
the
Adam?
trends. Yeah.
Trends.
Yeah.
I mean, I don't know what you're talking about, but trending is a good way to do it.
It has to be a statistical base, but also I think allowing human in the middle at this point, especially with the ethics and what you might be trying to drive to in various ways. As a shop owner, maybe you have kids and you're not trying to sell a lot of sugary drinks. So, okay, that it might say sell them sugary drinks, but you might want to sell them sliced apple packages or something more healthy.
Or maybe something that's sugary but not made of sugar.
Okay, I
Hmm.
like that.
It doesn't have
My
to be
wife.
sugar in the drink.
That is Susan, my wife.
Thank you, thank you, thank you, Susan.
Sugar.
Now I would
Oh,
like
sorry.
to ask the other students, what do you have any use case in mind for agents? And let us see how we can apply responsible AI for that.
Thank you for letting me join the class and contribute. I learned a lot just by those questions.
Thank you.
Thanks a lot, Yash.
Thank you. Thanks a lot, Adam. Yes. So the floor is open for questions. I want to do this exercise with each of you, where you think about one use case of an agent, and we will figure out how we can do the agent, responsible agent for that. Would anybody like to volunteer and go first? Yeah. So can Renee do that? Like, Renee, can you come up with the use case? And can we do the brainstorming together on how agents can be done and how can they be made responsible? Would you like to hop in and have a brainstorming here?
Okay, yeah, maybe it would be great to have an agent that could respond to the email, which I do not want to reply by myself, because they might be boring, they might be questions which I do not care about or which are not helpful for me.
Can you
So
repeat it?
I would like to find an agent that would be able to filter my email
Okay.
and would be able to respond automatically to certain email.
Mm-hmm.
For sure, should only be the email which are not highly important. Sometimes, you know, you have a lot of generic questions or
Got it.
which are maybe not important. So this kind would be helpful already.
Okay. That's a very nice use case.
So how would you start that?
Yes. Yes. So here you were very clear with the goal of the agent, and you are very clear with the task of the agent. To do this task, do you think we need one LLM or multiple LLMs?
I think one might be enough because it is not too complicated, I guess.
Okay. And my next question will be, does it require short-term memory or long-term memory?
It might be long term
Okay. Why so?
because they will be repeating email from a same sender, which will be come again in 1 year, or maybe it should even remember what the LLM told the receiver about a few months ago.
Okay, okay, okay.
So
I get
because
that.
maybe I do not want the agent to be to appear like a basic chatbot.
Okay,
I mean, it would be a bit like a chatbot, but if the people know immediately that it is an AI agent, and if the people discover that the agent does not remember what you were talking about with him maybe last week, the people will get annoyed. And I want
got
to
it.
avoid this.
Yes.
So yeah,
So,
long-term memory.
okay. And my next question will be, if you had to do this, do you think you need multiple agents or a single agent is enough?
I think, no, this is a question which I would ask you because I don't know. I'm not sure.
Okay, okay.
Maybe would I need multiple agents for a different type of email? Or would one agent be enough to handle all the different type of email?
Okay, maybe we have categories. And each of these, when I say category, okay, Ananya is telling here. 2 agents maybe, one to filter low priority emails and one to answer like me. Okay, yeah. So they have different goals, their tasks are different. And one can delegate to the other. So there can be a manager agent which overtakes of the entire thing, and there could be this multi agents which each of which can tackle one thing. Like there could be one agent which detects spam, one agent that puts up the priority emails first. There could be one agent that is answering emails. So just in the context of emails, there are multiple agents. Now, the last question for this session for today is, what do you think about responsible AI in the context of the agents that we just discussed in the last couple minutes related to email?
I mean, in my case, or in an email case, it should be for sure a limitation depending on a place. Do I use it private? Or maybe do you make decisions which are really important to a lot of people? So that would be a responsibility. So the agent should not give kind of like an instruction to do something which might affect a lot of people.
Okay.
Maybe he should not make a layoff in a company by himself. So that would be a disaster. We do not want the agent to fire people without the permission of the owner of the agent, maybe.
Okay, okay, got it.
Or it could be even in a political way. So imagine in a newspaper, a journalist would use an agent and it would give kind of like a fake news. That would be also something we do not wish to do. So that would be a case of responsible AI.
Got it. So we will wrap this session. It's past our weekly WeeklyWed session, and I would like to tell that we are having an Agent AI course, and there is a MailChimp that I'm sharing here. Please sign up for that, and you'll be able to get all the details about Agent AI. It's a course by Sudha from Business School of AI, and you will get to learn from the beginning to the end. Whatever we have covered in WeeklyWed, will be dealt there in a very extensive manner and in a lesson format. Also, there will be live labs there. So will the course be different than the one on LinkedIn? Yes. LinkedIn course is by Sudha, and that is also on agents. This one is from Business School of AI. Here also we are trying to tackle agent AI. Okay. Thank you, everybody. Save the MailChimp link and subscribe to the newsletter. Share it with anybody who's wanting to learn more about agent AI. I'm sure that you have seen the last couple of sessions where we dwell on different aspects of agent AI, and you have seen what are the topics that we can cover and how is the mode of lessons. Thank you. Thank you for joining WeeklyWed. We will meet in the next WeeklyWed at 9 a.m. Pacific time next Wednesday. Thank you.
Thank you.